Today we'll be talking about data structures. Before we get into the material, I realized there are a few things I didn't point out in the last segment. The first are the keyboard shortcuts. You can modify your keyboard shortcuts by navigating to the Tools menu and selecting the Modify Keyboard Shortcut option. This should give you all of the keyboard shortcuts. I find it useful to scroll down to the R under Scope, and I'm looking for Run Current Line is Control Enter. Run Current Line without moving the cursor, Alt Enter, and there's a few others you can go through and see what the settings are on your computer. Especially if you're using a Mac, then you want to make sure that you have the right keyboard shortcut. This. The second thing that I wanted to explain was the working directory. I can check what working directory R is in using the function getWD, get working directory. So all a working directory is a file path to the folder on your computer where R is pointing. This is important when you're reading in files, and sometimes you'll receive an error message that a file isn't available, and it's usually because of a working directory issue. You can set your working directory a few ways using the function setWD. You can also select it from the session menu, set working directory, to your script file, wherever your script file is saved, or you can choose another directory. All right, so I have a new session open, and I'm going to create a new script. I already have a new script open, so I'm going to save it as, I'm going to give it the same naming structure as the part 1, change this to part 2, and now it appears in that folder for scripts under the folder, the data science course folder that I created. We'll learn about a few different types of data structures. The first type we'll learn about is vectors. So a vector is a sequence of values with the same type. So it could be numeric or it could be a character. And we create vectors using the C function, which stands for combine. Let's create a variable called sites. And in that variable, we'll store the following vector of letters. Run this using the keyboard shortcut, and now it appears in my global environment, and I can see it's a vector of length 4. We can also look at the structure of that variable using the function str for structure. And we can see that it's read as this character, and it'll give you an output of the first few entries. Let's talk a little bit about slicing. Slicing is done using the brackets. In general, brackets in R means give me a component of something. For example, sites bracket 1 means give me the value for the first element in this variable sites. So the element in the first position is A. We can also give it ask R to give us a sequence of values. So give me the elements 1, 2, 3. So that's the first, second, and third elements in the variable sites. So A, B. This is the same. The notation 1, 2, colon 3 is the same as the C function. So it makes a vector in the same way that the C function does. For example, we would write size bracket C1, 2, 3, and that would be the equivalent of the 1 to 3. We can also ask R to pull out elements in different order. So we don't have to go in order. We can ask R, okay, give me the elements in this variable size that are in position, the 4th position, the 1st, and the 3rd. Then it'll return the values in the order that you requested them in. You can use a vector to get any subset or order that you want. With this vector, we can also do math. Similar to how we use R as a calculator, we can use built-in functions to do math on those vectors. For example, we can look at the length of our site. So that's sites is a vector of length 4. We can also look at the mean. Let's create a new variable, the data structure of this variable is a vector. So let's tell R, okay, create this new variable called density hectare and combine the values of 2.8, 3.2, 1.5, and 3.8. I ran this line and now it appears in our environment. I can see that it has a length of 4 and it's numeric. So we can do math on this vector. And I can use these built-in functions like mean or max. Give me the max value for this vector, or the min value, or the sum of all values in this vector, density hectare. There's a lot of built-in functions in R. One way that you'll start to learn about these more commonly used functions are by Googling how to calculate the mean of a variable in R. And by the end of the course, you'll get used to a lot of these functions. So don't be worried if a lot of these things are new and unfamiliar. That's why you're taking this course. So far, we've worked with data with no missing values. But in reality, we work with data with lots of missing values. So how does R, let's see an example of how R treats no values. In our tidy data module, we learned about the best practices around no values, right? So blank spaces or NA. Let's imagine that our vector density hectare has an NA value in it. So let's write in an NA value for the 4th element and try to calculate mean density hectare, the mean for this vector. Right, what do you expect to happen? Let's see, if we run this, R returns a value of NA. Because it's hard to say what a calculation, including NA, should be. R doesn't understand that. So most calculations return an NA value when NA is in the data. To get around this, you can tell many functions to remove the NA before calculating. And that's using a pretty common argument called NA.remove. And if I type partially typed, you can see it appears in this yellow box, describes what it means. So it's a logical value indicating whether NA value should be dropped from the calculation. So that logical value is true or false. In this case, we want NA.remove equals true. And we want those NA values dropped. So now we can calculate mean for the values that are not NA. We've been working with single vectors. Let's look at examples of working with multiple vectors. And in particular, let's talk about vector math. So vector math combines values that are in the same position, and it works on each element, so operating one element at a time. Let's look at an example of what that means. Let's recreate these density hectare variable, 2.8, 3.2, 1.5, and 3.8. I need to run it, and let's create a new variable called hectare and combine the values of 3, 5, 4.9, 2.7. And let's create one final variable called total number and do vector math. So density hectare, I'm using that tab, and autocomplete density hectare times area hectare. And if I run this, we get this variable total number stored in our environment. It's a length of 1 to 4, and we can print out the results. So what R is doing is it's multiplying, right, element by element. So 2.8 times 3 is 8.4. 3.2 times 5 is 16, and so forth. Returning to the brackets, we can also subset using multiple vectors. So, for example, we can subset the area variable based on conditions from the sites variable. So if I told R, okay, R, for all this elements in which sites equals A is true, return the value of area hectare. So let's first see what this internal portion is doing. It's creating this logical test and it's saying, is this position or element equals to A? And let's look at sites, right alongside with it. So it's asking, is the first element in sites equal to A? Is true. Is the second element in sites equal to A? True. Is the third element in sites equals to A? It's false, right? So now when we subset, we're telling our subset the positions, return the elements that where this logical statement is true. That's how we would combine multiple vectors when subsetting. And notice how I had to use the double equal sign. The double equal sign means equal to in most programming languages, whereas the single equal sign is a substitute for the assignment operator. But you can see how if your code gets really dense and you have a single equal sign followed by double equal sign, visually it can be confusing. That's why people prefer to use this assignment operator to assign values to a variable as opposed to the single equal sign. So we'll stick with the assignment variable. We can also use those other mathematical notations. So I'm going to, we can use not equal to using the exclamation point. And this will subset area hectare for all the positions where sites does not equals to A. So that's the third and fourth position, right? The third and fourth position area hectare. And I'm going to copy and paste this 1, 2, 3 times so we can see the other mathematical operators like greater than, sites is greater than, no, sites is a letter. So let's do the opposite. Let's do sites where area hectare is greater than some value 3. I'll change all of these A's to 3. Or greater than or equals to 3. Or less than 3. So R recognizes those notations. So we're subsetting, look, I made lots of typos. I copy and pasted in one line, but didn't follow through on the others. Okay, so now what we're telling R is whatever elements where area hectare is greater than 3, return those values for the sites variable. And if you're a very visual person, let's look at those positions lined up together so you can see we're asking R, what elements are greater than 3, and it is the second element. So it'll report the sites where this element is greater than 3. So it'll return an A for this line. And if we look at greater than or equal to 3, please scroll back up a little bit. So greater than or equal to 3, that's the first position and the second position. So it'll return the values of the first position and the second position in sites. It's important that you code alongside with me. You might find that having the YouTube video open in YouTube with your RStudio, kind of set up right next to it, because this exercises your typing muscle memory. Coding feels different than writing a paper, and it's important to exercise that muscle memory, especially for all these keyboard shortcuts and brackets. All right, the next type of data structure that we'll learn about is data frames. So data frames are probably one of the more common types of data structures that we'll use throughout the course. A data frame is a list of equal length vectors grouped together. And we can build a data frame using one of these are built-in functions. So let's create a data frame called surveys by using the data.frame function. And let's build in the sites, density hectare, and area hectare vectors that all have the same length. I know that because I'm looking here in the environment. And when I run this, now we should see our surveys object. And I can see those 3 variables, and it's telling me it's 4 observations, so 4 rows. There's a few useful commands that you'll get into the habit of using. The first is the str that we've seen before. So let's look at the structure of surveys. So now we can see that the data structure is a data frame with 4 observations. So that's 4 rows and 3 variables or 3 columns. Right? We can look at the type of columns, and this is a character, numeric, numeric. We can also look at the length of surveys or the number of rows using nrow surveys, or the number of columns for ncol and col. And this might be useful if you're running a loop and you want to know how many loops to run. And we'll see that later in the semester. We can also subset on a data frame similar to how we're slicing or subsetting on a vector. But a vector is unidimensional, and a data frame is multidimensional. Right? There's a row and a column. So we need to specify both. To specify the element in a data frame, we need to indicate both the row and the column. And I might clean this up to subset the element, to subset, how about elements in a data frame? We need to indicate both the row and the column, and the notation is the brackets again. For a vector, we saw that we only had to indicate one value because it's unidimensional. But a data frame, we have to give it a row, comma, column. Let's see an example of this. Let's subset our data frame surveys by row 1 and column 2. So it's giving me the value of in row 1, column 2. And let's view surveys to show what R is doing, right? So row 1, column 2. So that it's returning the value in that position. We can subset using a sequence of rows, so multiple rows and multiple columns. So let's tell R, let's subset the surveys from rows 1 to 2 and columns 2 to 3. And you can see it's returning the first and second rows for the second and third columns. We can subset, let's say we want all the rows and only one column. When you want all the rows or all the columns, you leave that position blank, and R understands that. So in this case, we leave the first argument blank, and in the column, we want the third column. Right, so it's giving you all the values in all the rows for the third column. We can also call those columns by their name. So here I'm saying, okay, R, return the values of the column area hectare from the surveys data frame. Or maybe we want multiple columns like area hectare and sites. And to do multiple conts, we need that combine function. Move this up just a little bit. So we see area, hectare, and sites. An easier way is to call the column using the $ operator. That is the symbol to call a column within a data frame. So, and you see that the drop-down kind of options pop up. So let's select the area hectare. So it's giving me all the values in this column. Or, okay, we've been working with data that we've created within R, but most of the time you'll be reading in external data from a .csv file, from a separated file, using the read.csv, external data. The main argument that R expects is the location of the data. Now for this video, I'm going to copy and paste a link, and then we'll see an example of file paths. Let's create a new variable called shrub data, and we'll use this variable to store our CSV, our data frame. So let's use read.csv, and you can see that the first argument is the file. So the file location. We can use a URL or we can use a file path. Let's use a URL first. All right. And now we can see that it downloaded this data set and stored it in a data frame called shrub data. And it has 10 observations, so 10 rows of 4 variables, or 4 columns. Now let's say it's a file on our folder. I don't have a data folder. So I'm going to take a minute to go into that higher level data science course folder. Oh, I did create a data folder. And now I'm going to write that CSV. This is to write that data frame to a CSV file onto my computer. And it expects a path. So I'm going to say data. No, I need the shrub, the name of what I want to write first, and then the path. So the path will be the folder data and the name, dimensions.label.csv, and quote equals false because R puts quotes around all the values. Quote equals false, and I'm going to look at my data folder. There's nothing in there now. I think I wrote this right. Okay, and now I wrote that file as a CSV into the folder. We'll talk much more about paths next week, but I wanted to give you an example of how you would use read CSV with a path. So let's do that again with the path now that I have the data on my computer. So read.csv. Remember, I'm in this higher order. This is let's look at my working directory. It's in the data science course, so I need to designate that. There's this folder, and the file is called dimensions-label.csv. And And I'm going to run this. And I could have deleted this first so you can see how it's reading it from my computer and not being stored. All right, the last type of data structure we'll learn about are factors. Let's look at the structure of our shrub data. And you'll notice that the shrub ID is this character variable, and that's, it's this string of letters and numbers. And the newest version of R now recognizes that these are not factors, that these are indeed a character, and that's what we want. This is a special data type in R for categorical data, and it's useful for statistics, but it can mess up many aspects of computation. And it caused a lot of issues, and our community decided that it was better to set these strings to be read as characters instead of factors. All right, in this segment, we learned about data structures. We started out with these unidimensional vectors and saw how to slice or subset. We know that we can do math on a single vector as well as how R calculates math using multiple vectors, combining element by element. We had an introduction to data frames, and by the end of the course, you'll know all about data frames, as well as some of the useful functions to work with data frames. We saw how to subset data frames using the bracket and row column notation. And we saw how to read files into the R environment, as well as a sample of how to write them into a folder on your computer. And next week we'll talk more about paths in more detail, as well as some tips for basic reproducibility. In the exercises this week, you'll be working with this shrub data, calculating things like the volume of the shrub canopy using these different variables that are stored within the data frame. So work on the exercises. If you get stuck on something, use the coding lab discussion board to ask questions. And if you fly through it, check out the discussion board to see if somebody needs help. I'll be checking the discussion boards too, so I'll see you there.